Hello everyone, welcome back to my YouTube channel, Just for Math. In this video, I'll be talking about understanding the concept of annuity. Let's begin by defining some basic concepts. First, I'll define what annuity is all about. Annuity is a series of equal amounts of money paid at regular intervals over a certain fixed period. So once you receive an amount of money from an organization or from an investment over a given period of time constantly, and in fact the money is usually paid annually. At the end of a particular year you get a particular amount of money, and then the second year you get the same amount of money, the third year, the fourth year, for a given period of time. Such amount is referred to as annuity. All right, now amount of an annuity is the total of the sums of money received by investing annuity immediately they are received for a given period of time. So once, for instance, you're supposed to receive an annuity of say 10,000 naira at the end of each year for say 5 years, and at the end of the first year you receive the 10,000 naira and invest it for the next 4 years. At the end of the second year, receive the same amount of money, 10,000 naira, invest it again for the next 3 years. At the end of the third year, you collect that same amount of money, invest it for the next 2 years. And once you do that up to the fifth year, the total amount of money you receive at the end of the fifth year is what is referred to as amount of an annuity. Let's derive a formula for amount of an annuity. So let's assume you have you're going to receive an annuity of P naira. You receive an annuity of P naira, okay, over the period of n years, over a period of n years, and you intend to invest the annuity annually. Immediately you receive it at the rate of R%. Okay, now to calculate the total amount you receive at the end of the 10th or the nth year rather, this is how we go about it. So at the end of the first year, you receive an annuity of P naira, right? Once you receive that annuity, you invest it for n minus 1 years, so that the amount you receive after n minus 1 years will be equal to P naira times 1 plus R raised to power n minus 1. So mind you, these investments will be computed based on compound interest. Don't forget that the amount one receive when you invest P principal P for n years at R% rate is, according to compound interest, is P times 1 plus R raised to the power n according to compound interest. So this is the same amount that you receive when you invest the annuity for a given number of years. Okay, and this particular activity will go on. All right, at the end of the second year, you're going to receive an annuity of P naira again, annuity of P naira, and you invest that annuity again and receive an amount after n minus 2 years. You receive amount after n minus 2 years, which is going to be equal to P naira times 1 plus R raised to the power n minus 2. Okay, this process will go on like this. Let's say up till at the end of, say, the nth minus 2 years. Okay, at the end of n minus 2 years, all right, you receive an annuity of the same amount, p naira, so that when you invest this particular annuity again, the amount you receive after n minus 2 years, which is actually after 2 years, because when you open the bracket, n minus n is 0 and minus times minus is plus. So this is going to be after 2 years, okay, will be equal to p naira times 1 plus r raised to power 2. Okay, and also the annuity received at the end of n minus 1 year, nth minus 1 year, is still going to be equal to p naira, so that you invest that same annuity and receive an amount after n minus 1 years, which is just 1 year, and that amount will be equal to p times 1 plus r raised to power 1. And finally, at the annuity received at the nth year, the nth year annuity will be equal to p naira, and this amount cannot be reinvested because that is the last year of the annuity, or the payment of the annuity. Okay, so our interest is to get the total amount of money that you will receive at that nth year. That will be the sum from the nth year, the sum of money gotten from the nth year to the nth minus 1, nth minus 2, and up to the first year, right? And up to the n minus 1 years. So we have amount of annuity, amount of an annuity, which I will represent with the symbol AA, will be equal to their nth year annuity, p naira. Let's ignore the naira sign and put it in at the end of the whole process. So p, because the currency can be, the amount can be in any currency, so p plus p times 1 plus r plus p times 1 plus r raised to power 2 plus dot 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 plus p times 1 plus r raised to power n minus 1. Okay, that is n minus 1, n minus 1. So that at the end of the day, when you factor out p, this should be equal to 1 plus 1 plus r plus 1 plus r raised to power 2 plus dot 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 plus 1 plus r raised to power n minus 1. Okay, now by close observation, you observe that the series in the curved bracket is actually a geometric series, so that we're going to make use of the formula to calculate the n terms of the sum of n terms of a geometric series Sn, which is given by a times r raised to power n minus 1 over r minus 1, where a in this case is equal to 1, the common ratio CR, or which can also be written as R, is equal to 1 plus R. Okay, and we're calculating the sum of the n terms, right? So that this formula would then be equal to P times A, which is 1, times R, in this case is 1 plus R raised to power n minus 1, okay, divided by 1 plus R minus 1. Alright, so let's do some other substitution. Let R be equal to 1 plus R. Now if R is equal to 1 plus R, it means that the formula can be written as amount of annuity equal to P times big R raised to the power n minus 1 over big R minus 1. So here's a formula that we are going to use to solve for an amount of annuity for n years. All right, for n years. So given small r to be the interest that will be paid at the end of each year of investment. Okay, now let's see some application. Okay, here's a question. Find the amount created by an annuity of 60,000 naira payable yearly for 4 years at 4% interest. Solution. Now let's write out the parameters. The annuity here is 60,000 naira, and this amount should be reinvested for 4 years. The n in this case is 4 years, and the rate small r is 4%. Let's recall the formula. Amount of an annuity equal to P times big R raised to the power n minus 1 over big R minus 1, where big R is equal to 1 plus small r, and in this case we have it as 1 plus 0.04. that is going to be equal to 1.04. Substituting these parameters, we have the amount of an annuity to be equal to 60,000 naira times 1.04 raised to the power 4 minus 1 divided by 1.04 minus 1, and here is going to be equal to 60,000 naira times, when you punch the value 1.04 raised to the fourth power, that will be equal to 1.16985 or 86 to 5 decimal places, minus 1 over 0.04, because 1.04 minus 1 is 0.04. Okay, so that the amount of an annuity AA will then be equal to 60,000 naira times 0.16986 divided by 0.04. Okay, so that we have this to be 60,000 naira times, when you divide the value, you have 4.246464. okay, and expanding this, multiply 60,000 by the decimal number 4.246464. that will be equal to 254,787 and 0.84, which is A84 kobo. Now here's the amount of an annuity that is created by investing the amount of 60,000, the annuity of 60,000 for 4 years at 4% interest. Okay, thank you guys for watching. I hope you understand the concept now, and hope you enjoyed this video. If you do enjoy the video, kindly like, share, and drop comments right there in the comments area. Remember to click on the subscribe button in case you're yet to do so, and don't forget to click on the notification button to get notified whenever new content is posted. Once more, thank you guys for the love and for watching. Goodbye.